Welcome to a brand new section of this course, Advanced Expressions. In this section, we will dive into some of the complexities you can come across when developing a QlikView application. In summary, we will learn to expand the use of variables, to use conditional functions and if expressions, to handle advanced aggregations. So let's get to it. Now we move on to the first video of this section that deals with using variables. In this video, we will cover the use of variables up to an advanced level, but let's first get to the basics in order to move on from there. Now that we have reviewed the different ways in which we can use variables in QlikView objects, to store a value or string either static or based on a formula. This type of variable can also be used to receive and interpret input from the user. To store an expression definition that can be used in charts. The main difference between the previously mentioned options is that one calculates the output before sending it to the sheet object that makes use of the variable, whereas the other stores only the definition of the expression and the object using it is in charge of evaluating it and getting a result. Now, let's create a variable. We've already worked through the process of creating a variable in a previous video, and you've seen that it is fairly simple. However, let's make a quick review of the steps involved in using our airline operations document. Open the corresponding QlikView file and create a new sheet so that we don't mess up the objects already created. Name this new sheet Variables. Now go to the Variable Overview window by using the keyboard shortcut Ctrl Alt and V, or by clicking on the Settings menu and selecting the Variable Overview option. From this window, we are able to see the variables that have been previously defined. Click on the Add button and the New Variable dialog will appear, where we will type the name we want to assign to our new variable. The default name is Variable1. Change it to vtop and click on OK. The variable will be created and we will now be able to assign a value to it. To do that, highlight the new variable by clicking on its name and, in the definition pane on the lower part of the window, type the number 5. Then, to describe what the variable is for, in the comment field, add the comment, variable used to dynamically change the number of displayed values in a top N chart. It's important to first highlight the variable by clicking on its name before entering the variable's definition. Otherwise, the definition we enter will not be correctly applied. Our new variable will, for now, contain a simple and static value. We will use that value to manipulate a chart. Specifically, this value will represent the number of carriers that should be shown in a bar chart, based on their number of flights. Only the top 5 carriers shall be shown. Now click on the Create Chart button on the toolbar and select Bar Chart. We give the title as Number of Flights per Carrier. Click on Next and for Dimensions select Carrier Name. Now in the Expression tab, add this expression. From the Sort dialog window, make sure the carrier name values are sorted by Y value in descending order. Our new chart should so far look like this one. As you can see, the chart is a little clogged with bars in the limited space we have available. We need to limit the number of bars shown so that only the first N carriers are visible. N is the number that our vtop variable holds. Now go to the Chart Properties window and activate the Dimension Limits tab. Enable the Restrict which values are displayed using the first expression checkbox. Next, you need to set the configuration for the limit. The Show Only Radio button must be selected. From the drop-down list, the largest value will be selected. On the Values field, we enter our variable using the syntax $vtop. Lastly, the Show Others checkbox should be disabled. The syntax we use to enter the variable is called $expansion. In this particular case, the variable could have been entered without the $, but there are some circumstances in which it is a must, so it's a good practice to always include it. After finishing setting this configuration, click on OK and you can see that the chart is more readable. You can also change the chart's orientation to horizontal from the Style tab of the Properties window so that it's even more readable. The reason for using a variable to limit the number of dimension values shown in the chart is to enable the user to dynamically change it as pleased. There are two main layout objects through which a variable's value can be changed: the input box object, the slider object. We will describe the two of them and their uses. Let's first deal with using the input box object. The input box is basically an Excel-like cell on which the user enters values. An input box can hold any number of variables, each one with its own associated cell. To describe how it is used, click on an empty space of the Sheet workspace and, from the New Sheet Object section, select Input Box. The new Input Box dialog window will appear and the General tab will initially be active. From the Title field, we can assign a display text to be placed on the object's caption bar. Type Enter number of top values into this field. In the Available Variables list to the left, we will see all created variables. There is also a button to create a new variable, which is very convenient if we previously forgot to add the variable we want to use. We are going to add the vtop variable to the Displayed Variables list on the right. Do this by highlighting the variable's name and clicking on the Add button. Once the variable is in the Displayed Variables list, highlight it and the Label field, located below, will be enabled. On this field, replace the name of the variable with top values. There are other options that can be set in the rest of the tabs, but we can click on OK at this point, and the object will be created with just what we need. When the object is created, the input cell will have the number 5, which is the value we previously defined for our variable. If we click on the value cell, we will enter into edit mode and be able to change the variable's value. Upon doing so, the chart will be instantly updated to reflect the change. Let's change the variable's value to 10 using the input box object and see the effect on the chart. Similar to the input box object, the slider object is used to interactively change a variable's value from the front end. The main difference is the way in which the user interacts with the object. The slider object is a little more visual. To create a slider object, right-click on an empty space of the Sheet workspace and, from the New Sheet Object section, select Slider Calendar Object. The new Slider Calendar Object dialog window will appear and the General tab will be active. For a slider calendar object, the input style option can be set to either slider or calendar. The slider object is the one we will be using in this example, since the calendar object is used to work with date values. It's important to note that this object can be used not only to interact with variables, but also to make field selections. From the Data section, make sure to activate the Variable Radio button and select the vtop variable from the drop-down list. The Mode and Value Mode settings will be left with the default options. We must set min and max values to delimit the slider's range of possible values. Set the min value option to 5 and the max value option to 30. To specify that only integers should be used in the slider, enable the Static Step checkbox and set its value to 1. Click on OK and the slider will be created in horizontal form. It can be changed to vertical, if desired, from the Presentation tab of the slider's properties. Let me expand this. The initial value the slider will hold is the one we previously set, the vtop variable 2. To modify the value, click on the thumbtack and drag it to its desired value. The chart will automatically reflect any change made to the variable and, at the same time, the value stored in the input box object we previously created will be kept in sync with the slider object, since both objects are using the same variable. Previously, we used a variable to store a static value. That is to say, the value was not based on a calculation, and therefore didn't respond to user field selections. We will now create a variable with a dynamic value, one that responds to the document state and calculates an output value based on user selections. To keep this example as simple as possible, we will create a value that will hold and return the total number of FTEs based on current selections, and use that value in a chart expression. Let's go to the Variable Overview window and click on the Add button. From the New Variable window, type VTotalFTEs to name the new variable and click on OK. Next, highlight the variable and type the next expression from the definition pane. Click on OK to close the Variable Overview window. We will now proceed to create a new chart in the form of a straight table with carrier name as the only dimension. So, let's right-click and select the option New Sheet Object and select Chart. We create the new chart that is straight table. Keep the dimensions as carrier name. Now add the expression sum in parenthesis hash equivalent FTEs $VTotalFTEs. Click on OK. We give it a label, FTE to total, and go to the Number tab. From the Number tab of the Chart Properties window, assign a 2-decimal format and specify it to be shown as percentage. So, this is our final result after rearranging the tables. These settings will result in a table with a list of carriers and the percentage of FTEs each of them contributes to the total. Let me rearrange these elements. Notice we have included our VTotalFTEs variable as the divisor with the $expansion syntax. Since the variable holds a single value, all rows in the straight table will be divided by the same number, which represents the total number of FTEs employed by all reporting airlines. The numerator value, which is the number of corresponding FTEs, will be different for each carrier. Since the variable's value is an active calculation, the output value will respond to all user selections, and the chart will be updated to reflect the changes as well. So far, we've discussed variables that store a single static value and variables whose output value is based on a calculation. Now it's time to take variables to a new level and expand their usability. So, let's go to the Variable Overview window and add a new variable with the name of eFTEs. Let's add the contents of this variable. Similarly, add the comment to the variable. Notice the variable definition is almost the same as that of the VTotalFTEs variable we previously created. The difference, the equal sign at the beginning, though small, is in fact huge in terms of impact. After creating the variable, we head on to create a new chart in the form of a straight table with carrier name as dimension. Now add the expression. The new straight table will be created with the total number of FTEs for each carrier, just as if we had used a direct expression instead of a variable. Now let's move on to the $expansion syntax. We have been using a particular syntax to reference variables. It's called $expansion, DSE. It's good practice to always use DSE even when the variable to be expanded does not require it. There are, however, cases in which the DSE is ineffective on its own. When the variable's output value is a text string, the result of the $expansion will be a null or missing value because a text value cannot be interpreted numerically. So we need to either enclose the $expansion into straight single quotes or simply not use DSE. Here are the examples for this. It is also possible to create variables with parameters and then call them via a DSE specifying the parameter's value, thus allowing extended flexibility and reusability of variables. Now, let me show you the way how we create a variable with parameters. First of all, open the Variable Overview window and create a new variable. Name it eDeparturesPerformed_var_unit. Now, the variable definition is sum of departures performed divided by $1. In the comment field, enter variable to calculate the number of departures performed with variable divisor. close the Variable Overview window by clicking on OK. We already have a similar variable, called eDeparturesPerformed, which is used to store an expression that calculates the number of flights performed in thousands. The difference this time is that we are inserting a parameter as the divisor. This parameter is represented by $1 and will allow us to use the same variable to obtain the corresponding expression and calculate the number of flights performed in millions, thousands, units, and so on. To use the above variable in an expression, start by creating a new chart in the form of a straight table. We give the window title as number of flights and the dimension as carrier group, and we create 3 expressions. This is the first expression, and we provide it with the label number of flights. Similarly, the second expression, labelled number of flights that is in thousands, and the third one, labelled number of flights in millions. The only difference in these expressions, apart from the label, are the parameter values inserted into the variable. After properly formatting the expression values and the chart's presentation, you will have a chart similar to this one. A variable can have any number of parameters defined, all specified with a $sign and a number that indicates the parameter's number, like $1, $2, $3, and so on. Finally, let's discuss about $sign expansion. We've already discussed how storing expressions in variables can be a good idea for reusing expressions, easily manage changes in them, as well as for data consistency across sheet objects. We will push this idea a bit further by using those expressions variables to allow the user to switch among different metrics at his or her convenience. First, make sure the expression variables eDeparturesPerformed, enplaned passengers, and airtime are already in the airline operations document. We have already created these definitions. If you don't have these variables defined, define these before you proceed. Now we will add a new island table to the data model via a load inline statement. Open the Edit Script window and add a new tab at the end of the script. Name it Metrics. In this new tab, we will add the new table using the Inline Data Wizard dialog. For this, go to Insert, then Load Statement, and click on Load Inline. Let's add the column name. And now add the data. Number of flights, eDeparturesPerformed, enplaned passengers and enplaned passengers. Then we have airtime and airtime. This is the corresponding script that is generated. The first column of the previous table holds the metric names, which the user will be able to select from a list box. The second column holds the corresponding expression variable names, used to calculate any of the selected metric. Save the script and reload the script to add the new table to our data model. After the script is reloaded, you can find the new table added to the data model with metric name and eMetric. Then create a new list box based on the metric name field and place it in the variable sheet. Give the title as metric name and field as metric name. Once the list box is created, select one of its values and enter the list box properties window to enable the Always One Selected Value setting from the General tab. This way, we ensure that we will have something to calculate at all times. We are now going to create a new chart, whose expression will be dynamically changing based on the metric name selection. Let's define the settings of the new chart. Select the pie chart option in the Chart Type section and enter this expression into the Window Title field. Click on OK. Disable the Show Title in Chart checkbox and set the dimension as carrier group. Also set the second expression. Now, from the presentation window, enable the Limit Legend checkmark and set it to 15. Once the chart is created, we will be able to switch its active expression by selecting the desired metric from the metric name list box. So, click on Finish. The metric selection based on a list box works the same as having grouped expressions in the chart to be able to switch them with a cycle button. However, the list box selection makes it possible to change the metric on several charts at the same time, something that is not possible with the cyclic expression method. Notice how we have also set a dynamic chart title that changes according to the metric selection. Be sure to save the changes we've made to the airline operations document before continuing. Now that we have reviewed the different ways in which we can use variables in QlikView objects, let's complement the acquired knowledge by exploring other uses of advanced expressions.